a definition for that, and you see the center-defined definition is taking basically always the clusters that come out if the density attractor, which is basically attracting to a maximum, is above a certain threshold. And you can do for a given threshold here, you see I have two clusters, this cluster and this cluster of my data. And if I'm having a different threshold, I may get 3 clusters. It really depends on that threshold. And you can have a different definition where you combine all the clusters that are linked by a path, which is above that level. So if I take this path, then I get, instead of 3 clusters, I get only 2. And this is basically, if you do that, giving you a certain cluster definition. Now you see a 2-dimensional example here. You see the plane of this threshold moving up, and you see the type of cluster that you get. You get arbitrary shaped clusters, which is nice. And you see basically how this develops over time. And you have another parameter, of course. The other parameter is the kernel, and the kernel is basically defined by the sigma. And you see if I'm modifying the sigma, I also get a different number of clusters, right? From having many clusters in the beginning to having only a few in the end, depending on the sigma level. So this is actually the basis for the Denclu algorithm, which is quite general. If you know the clustering field, you know there are different types of clustering algorithms like density-based clustering. dbScan is one of the famous representatives. And this kind of idea can generalize this. If you just set the sigma of the kernel function to the EPS parameter of the dbScan algorithm and the Xi value to the min points value, then you get the same results at dbScan.